Welcome to the solution video for the sample data challenge. Let's go over to Visual Studio and start with a new project. Let's create a console app. I know we're going to do a class library for our challenge, but I think a console app to start with and then add a class library to it later is probably the easiest thing to do. So we'll call this console UI, and the solution name is going to be the sample data challenge app. Hit create. And once that gets created, what we'll do is we will eliminate the console write line and instead add our console read line at the end. Now let's add our class library. New project. And let's look down here. We can actually just do a filter here by library. And we get class library. We'll do .NET Standard. That's the best if you can do it, just because of the fact that it works on so many different platforms, whether it's .NET Framework or .NET Core, UWP, Xamarin. It works with everything. Okay, so we hit next, and we'll call this our sample data library. And we'll delete class 1. And we'll add a new class to this. We'll create just one class, I think. I don't think we need to create multiple. If I was going to do this for an actual application where I'm going to create this tool to be reused over and over and over again, I would probably create one class per data type. So I'd say, okay, here's the strings, here's the doubles, here's the ints, here's the bools. That way it's, I don't know, it's a little more segmented. But even then you're going to have some problems, like with string especially. Does first name and last name, they are strings, so is that a random string or is that something special? So in this case, we're just going to do one class. Let's call this class sample. Make it public static. We're not going to store data in here. We're going to keep it static. That way we don't have to instantiate it. We can just say sample dot and whatever we're going to do. So in our primary challenge, it said, let's create some sample values. The first one was a Boolean. So let's do that. That's going to be a pretty straightforward one. So public static bool generate random bool. And instead of putting it into a variable and then returning it, I'm just going to return it all in one line. So return, well, I do have a problem here. And this problem is that if I make this static, which I really wanted to do, but if I do, then generating that random number, I have to pass in a random instance into this class. I don't want to do that. Otherwise, what happens is I instantiate a new random for every method that's called. And then in theory, if we call them fast enough, we'll get the same value for two different calls. We don't want that. So let's make this not static, and we will say that for our constructor, we're going to have above it a random, let's call it R&D for random. Let's call it underscore R&D. No, just R&D. Equal, or just semicolon, and say R&D equals new random. Now we're not going to pass in a seed value, which means it's going to be seeded based upon the current tick of our time, which is fine. Because what we'll do in every method is do R&D.next, ensuring that it's a random value, or as close to random as we can get using this simple class. It's pseudo-random, which is totally fine for this kind of work. It's not fine for encryption. But we're not doing encryption. We're just going to do simple sample data. So random Boolean, we're going to do is say rnd.next double. And next double, what it does is it returns a value that's greater than or equal to 0 and less than 1. So somewhere between 0 and 1, not including 1.0. So therefore, what we're going to do is say, if it's greater than or equal to 0.5, then that's a true. Otherwise, it's a false. Notice this right here is a comparison, and that comparison outputs a Boolean. Notice if I hover over the greater than or equal to, it says that's a Boolean. And so it's going to return a true or false. If this is true, it returns true. If it's false, it returns false. And since I put my value right in the middle, then I'm saying, okay, half of them are going to be true, half are going to be false. Now I said greater than or equal to 0.5 because we do not include 1.0, but we do include 0.0. So I wanted to make sure that I was trying to get as close as possible to half, which would include the 0.5. Okay, so that should return a Boolean, a random Boolean. Let's make sure it does. So what we're going to do is over here we'll say sample, and let's call it sample equals new sample. And it says, hey, you got a problem here, but if I control dot, I can add a reference to sample library. That's going to add a reference to our class library and add a using statement up here. And now I can say, let's do a for each here. Actually, not a for each. Let's do a for. So for 0 to less than 10, which means I'll get 10 values here. And we're going to do a console write line where we say sample dot generate random bool. And that should show us 10 values of true or false. And hopefully we don't get all of one kind or the other, or at least not twice in a row. We have true, false, false, true, false, true, false, false, true, true. If we do it again, we should get a different value. True, false, false, true, 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 false, false, true, false. So we do. Now, just know, I did say something that may throw you off a little bit. We could, in theory, get all trues or all falses. If you flip a coin, it's, in theory, random. But it can come up heads multiple times in a row. In fact, in my testing, I was doing 5 instead of 10, and I actually had 5 falses all in a row, which concerned me because that doesn't seem like it's random, but in actuality, it is random. Because I tried again, and it was back to that kind of breakdown of trues and falses. So just know if you do see all true or mostly true or mostly false or all false, it's probably not a problem unless you get that every single time. So there's our sample Boolean. Let's go over and do our int. So public int generate random int. And this is going to have a range to it. So I'm going to say int floor, meaning the bottom number. I'll start off at 0 as a default. Int ceiling, which means the top number we're not going to hit, we're going to go up to. And we'll say it's 100 by default. That way we have some default values just in case the user does not want to put in these values. These are pretty standard 0 to 100 numbers. So with this, let's return rnd for random.next. And again, random.next and random.next double, what these are doing is going off the next random value in line instead of instantiating this new random. You don't want to reinstantiate this. Do it once. That way your numbers are random based upon that random number. Otherwise, you could have 2 numbers that are instantiated at the same tick, and then you'd have the same value for 2 different, in theory, random numbers. So always use next. Okay, and we're going to say start at the floor and go to the ceiling. And that should return a random int for us. Let's find out. We'll do random int instead of random bool. We'll run this again. We get 53, 84, 58, 67, and so on. All right, all pretty high numbers. Let's run it again. This time 36, 33, 21. So you have lower numbers as well. So this is truly random, but you'll find that it feels there's an 8 and a 5. So it feels like sometimes when you first look at a set of numbers, you may say that doesn't feel random. but that's because it is random. And sometimes random looks like it has a pattern. So just be careful of that. Run it a few times and make sure that it's not the same pattern over again. Okay, so we have our Boolean, we have our int. Now we need our names. So first name, last name, or full name based upon a text file or text files. So how are we going to do that? Well, let's start by actually creating some text files. So in my D demos folder, I'm going to create a text document. I'll call this first names. And we'll open this up. And Tim, Bill, Frank, George, Mary, Sue, Greg, Bilbo, and Martin. Okay, so notice that the order here doesn't matter. The number of them doesn't matter. I mean, I have more first names than I do last names. That's not a problem. All we're doing here is create a simple list. You can go on the internet and find 1,001 first names and paste it into this file. Same with last names, 1,001, paste them in. Probably a better sampling to do that, because you may have noticed, especially if you are not from the US, my names are not representative of a broader culture. Okay, they're very simple names. They're very generic names. You may want to have names that are more fit your culture or fit a wider culture, so you have more opportunity to see some of those edge cases like special characters or things like that. Spaces in the name. So last name may have, St. Andrew is the last name or whatever. Well, you're going to have a period maybe or a space, or there's a lot of different things you could have, dashes, and so you might want to include those intentionally into your first and last names so that you can handle those edge cases and make sure they're handled well. Don't get caught up in the idea that your cultural viewpoint is the only viewpoint, or that what you see on a normal basis is what the entire world is. Okay, so be careful of that. But this is a very simplistic version here. We're not going for super complex or full. Okay, so now let's go back to our code. We're going to say public string generate random first name. Okay, and the first thing I want to do is I want to get a number, and that number is going to be the number of items in the first name text file, which means I actually have to load the first name text file. So let's add a using statement up here for system.io. And then here we're going to say string array names equals file dot read all lines. And we're going to pass in our file path. Now I'm going to hard code this. I think what would be best is to put this into an app config file or an app settings.json file that we can pull it out of there and change it, whatever. In our case, we're focusing in on the random part of this and on the generating sample data. We're not focusing in on making a full application. So this is where I'm hard coding this, is just a way to not get off track. So I'm going to say D demos. Notice the @ symbol allows me to do single slash instead of double slash. So first names.txt. So that's all the names. Now I can say random int equals generate random int. I want to start at 0, and my ceiling is going to be names.length. Okay, remember, it will not take the upper value. So if I have a length of 5, that means 0 to 4. That's not a problem because I'm not keeping the 5, I'm saying 0 to 5 minus 1 essentially, so 4. So that's our random int. Now we can say return names at position random int. And that's going to return the name from that row. All right? Let's do the exact same thing. So we're going to copy and paste this, only with the last names. So generate last names. So last name. And we're still going to generate the random int. We're still going to return the last name. I'm going to do one more before we're done. And that's going to be public string generate random full name. And now we can say return. Let's do a string interpolation here. We can say generate random first name space, oops, it's a method. And then generate random last name. So all we're doing there is calling the two methods we already have and put them together to get a full name. So now we have 3 new methods to try out. Let's try them out. So we're going to do, instead of generate random int, we're going to say generate random first name. Let's try that first. And there's our list. Greg, Mary, Bill, Tim, Greg. Notice that we have Greg twice. We have George twice in a row. We have Bill twice, Bilbo once. I don't see Sue in this list. So it is not pulled sum, it's pulled sum twice. And that's what random is all about. Let's do the same thing with last name. Make sure this looks valid. Smith, Corey, Jones, Martin, Baggins, Corey, Baggins, Martin. So a lot more repetition just because we have less to pull from. That looks right. Now let's do our full name. And this is where we shouldn't have as much repetition because it's randomly putting a first name with a random last name. So even if we have Tim twice, probably have a Tim Smith and a Tim Jones. There we go. Well, we do have 2 Tim Jones. How about that? We have a Tim Smith and a Tim Storm. So we have got some, 4 in a row we had Tim. But again, that's random. We do it again, we'll get something entirely different. In this case, we have a couple of Bills. We have 2 Bill Baggins. It'd really be helpful if we had more than about 5 last names. But that is our random full names. So that covers the primary challenge. We've created a random Boolean. We've created a random int. We have ranges for those. We have random names. First name random, last name random, and full name random based upon those text files. So now let's cover the bonus challenge. Let's start with our random double. I'm going to put it up here next to the int. Doesn't really matter where it goes, but random double, generate random double. And we're going to do the same floor and ceiling. Only the difference is with floor and ceiling, double, not int. Okay, we'll keep the same 0 and 100 value, but doubles are a little different. Okay, so let's figure out how to do a good double. Well, first let's do a double output equals rnd.next double. Notice you can't pass anything in, and it's going to give you between 0 and just less than 1. So it's not going to include 1, but up to 1. So random next double. Well, that only gives us a 0 to 1 range. We now have to put it inside the range of whatever we've been given. Now, we could multiply it by 100, and that would give us a range from 0 to 100, but what if the floor is 50? How do we deal with that? Well, that's where we have to do a little bit of math. So output equals, let's put this in parens, output times, and put this in parens, ceiling minus floor. Okay, so what this is going to do is it's going to take the top value. Let's just say we have 100 for the top value and 50 for the bottom value. Okay, let's say 25 for the bottom value, make it a little clearer. So top is 100, bottom is 25. That way, I would like to write things out so I understand, see the logic. So if we say 100 minus 25, that's 75. So the output times 75, which is going to give us a range from 0 to 75. Okay? But then what we're going to do is we're going to add to that the floor. And what that will do is if we have the range of 0 to 75 and we add 25 to it, now what's the range? Well, the range is now from 25 to 100. Okay, so you see how we did that shift? Let's make it as 2, not dash. Okay, so this formula right here, actually this formula, it allows us to get the range of 25 to 100 by how you multiply and shift things around. Okay, so it's a little tricky. I encourage you, write it down on paper. I try to do it here a little bit, but I even use my tablet sometimes to write this stuff down and kind of walk through it and see it. At least in my mind, I'm a visual person. Okay, so now we return output. So let's nothing is below 75, so 75.17 is the lowest. The highest is 174.81. So we're getting close to the top, but we never get outside that range. Okay, so we got our random double working. That feels a little bit like the easy one. Let's kind of collapse these down. Now, let's talk through maybe a little bit harder of one, and that is we have the random phone number and random zip code, but then we have that line at the end where it says support other numeric style formats without additional methods. And that may have tripped you up a little bit, but if we do this right, we can create one method that does this format, and then we can apply it with our phone number and our zip code. So let's create a public string, because it will return a string. Remember that phone numbers and zip codes, they're strings, not actually numbers, even though they have numbers in them. So we're going to say public string generate random, and let's call this number match, I guess is probably the best thing to do. And we're going to pass in pattern. Okay, what that's going to do is we're going to pass a pattern into it. Let's just say the pattern is like that, or like that, or something like that. Okay, so any kind of pattern you want, but the x's, the lowercase x, will be a number we want to put in there. So this is a number, this is a number, this is a number. Okay? But we're going to treat them as each individual as a number. And the reason why is because we may want to have the number be 0. So for example, a zip code can be 0, 0 is the first two numbers. If I said give me a random number between, I don't know, even if we said 100 to 99,000 or 100,000, between 100 and 100,000, which is technically the range for zip codes in the US. But if it returned a 100, it wouldn't return 00100. We have to pad that out. So instead, what I'm going to do is each one of these x's will be a random value. Now I've got an idea of how to do this. I have not optimized this way of doing it. And this is one of those things that you can often get tripped up on, is the idea of, well, is there a better way? Is there a more efficient way of doing it? My recommendation to you is get it down in code, get it working, then come back and optimize it later. So we're going to get this into code. It probably isn't the most efficient way of doing it. And if you want to keep going back and try to make it more and more efficient, test it out, cool, go for it. But we're just going to get this thing working. So let's say string output equals pattern. What we're going to do is put the pattern into our output variable. And we're going to say while output dot contains, and we're going to say lowercase x. Okay, so if it contains an x, go through this process. And once we're done, return output. So we're going to replace every x in here. Now you'd think we could do a string.replace. So if we said output dot replace, the problem is if you see this, it says returns a new string with all occurrences of a specified Unicode character are replaced. That's not a good idea because otherwise we'll replace all the x's with our number. That's not what we want. So instead what we're going to do is we're going to find the first character that matches our value. So int position equals output dot index of. We're going to find this character. So that's now the position of the first x. We know there's an x in there because it says, yes, it contains the x. So now we have that position. We know it's not going to be a -1, meaning it didn't find it. So we don't even have to do validation there. So now we can say output equals output dot substring from position 0 to position plus generate random number, random int, and we're going to say random int from 0 to 10, meaning it would be 0 and 9 essentially, plus output dot substring at position, and we're going to say to the output dot length. Okay, so what we're doing here, let's take this off. What we're doing is we're going to grab the first part of a string. So let's just say we have this string right here. The x isn't at position 0, it's at position 1, the first x. So position 1. And that's going to say, okay, from 0 to 1, give me that substring, which is just this character right here. Then give me a random number. Okay, so we'll have the opening paren and let's say a 5. So opening paren 5. Now give me a substring of this string right here, starting at position 1. Okay, and going to the end. I believe it's position 1. I don't believe it's position 2. So not +1. I think it's just 1. So we're going to find out. And then So it may have to be +1. Let's try the +1 to be sure. We're gonna step through this to make sure. Okay, but they haven't tested this logic. This is what I came up with out of the, kind of thinking it through. So we're gonna say substring a position +1, which means it should be 1 plus 1 is 2. So 0, 1. So starting at position 2, that's that x right there, and going to the end. All right. So, and actually, I don't have to specify the length here. I can just say start there and go to the end. All right. And it should be that it gives us a new value for output, which we then test to see if it has another x. We do the same thing all over again until you replace every single x with a corresponding number, which means that we'll keep the spacing, we'll keep the dashes, we'll keep the parens, or anything else. Let's try this. So we're going to put a breakpoint here, and we're going to say generate. We're going to say it right here. Let's not do a loop for this. Actually, let's do it. We'll pause after the first one anyways. And instead of passing in numbers, we pass in, let's do a phone number. Like so. There's a pretty standard phone number style for the US at least. So let's run this, and it should pause right here, and it does. So now we've got our output, which let's open up our locals window here and look at, we have our output right there. Let's pin this so you can kind of keep an eye on this as we scroll through or step through. I'm going to step over because yes, we're at position 0 right now, but now it's position 1. So it's okay. The int, because remember, int starts at 0. That's why it said position 0. But once we checked for the value of x, it's actually the first x is at position 1. Now let's do a replacement, and that should change our output value. Let's step over that. And now our output value is paren 1 xx paren. Okay, so that looks right. And if we step over this and keep doing this a couple more times, now our 1 4, 1 4 4, 1 4 4 9. Okay, see how it's kind of building this string out? Let's just hit continue here. And let's take it off here and let's just hit continue and see if it actually works. And it looks like we have a number of valid phone numbers. Cool. So we've got this pattern down. If we change the pattern up and say, you know what, let's do a zip code instead, which that's 5 X's and then 4 more after a dash. Let's run this. And there's some zip codes for you. So we've got this pattern idea down. This random number match pattern allows us then to say things like public string generate random phone number. And all we do here is return generate random number match and pass in the string of a standard phone number. Like so. And we can do the same thing for zip code. Generate random zip code. And a zip code is, again, those 5 X's in a row dash 5 or 4 X's after that. So there's generate random zip code. All it's doing is calling generate random number match, which means that if later over here we decide, you know what, I actually want a social security number, which we don't have a method for. But a social security number is 3, 2, 4. That's a US-based social security number pattern. We now hit run. And there are generated social security numbers. Now, of course, they're not real, although in theory, one of them could be, but that's not something we can predict. But that does give us that pattern we're looking for. So without adding any extra methods, we can generate any type of pattern we want. But if you want those specific ones, those standard ones of random phone number and random zip code, we now have those because they just call the generate random number match with the right pattern. Okay? So that's all there is to the bonus challenge. We have the random doubles. We have in a range. We have the random phone numbers and random zip codes as well. Okay? So that's it. Hopefully you kind of stretched and grew from this and saw something new. I'd love to see you tackle making this better, because I'm sure there's ways to optimize this to be a little better. Probably had something to do with how this string is built. Okay? That would be my thought. But give it a shot. Let me know we find out. Try and do some performance testing though when you do, because sometimes your assumptions aren't always what's actually happens. All right? Thanks for watching. And as always, I am Tim Corey.